Hello, my name is Kale Stedman, and I run the monitoring team at Demonware up in beautiful Vancouver, British Columbia. I'm here to tell you a story about my team's journey to assisted remediation, or as I've subtitled it, how we nearly built an auto-remediation system before we realized we never actually wanted one in the first place. I wanted to do this talk since I first came to Monitorama in 2016 and heard all about auto-remediation and all this cool stuff, and it's like, we're totally doing that. That'll solve all of our problems. I screwed up, but we'll get to that later. So let me give it a little bit of set the stage a bit and give some context here. So I work for Demonware, which is a wholly owned subsidiary of Activision Blizzard. And we work with game designers and developers from other Activision studios like Treyarch, Infinity Ward, Sledgehammer, Toys for Bob, Vicarious Visions, and many more, and help them create incredible games with amazing online experiences. We design, develop, and operate the services and run the infrastructure for a ton of online game features like online matchmaking, leaderboards, microtransactions, storage, clan and league services, among basically all kind of crazy stuff. Demonware code and services can be found in over 100 games, like all of the Call of Duty games, Guitar Hero, the new Crash Bandicoot, Tony Hawk, Cabela's Big Game Hunter, like all kind of weird stuff. I joined the company in 2012 as an SRE, which makes me 6 Call of Duties old. And Black Ops 2 was my first big game. Let's just say that launching a major AAA title with millions upon millions of users is non-trivial. So we support hundreds upon hundreds of games, each of which has an environment for each console, each platform that it's on. PS3, PS4, Xbox 360, Xbox One, Wii U, Nintendo Switch, iPhone, Android. I think we even have a Nokia N-Gage game or two. And each one of those has a development, staging, and production environment. These games live as a collection of services spanning thousands upon thousands of nodes. And through these, we support millions upon millions of gamers. So there's a fair bit of scale here. And since every game behaves differently, even the same game on different consoles, there's a whole lot of complexity in terms of the things that we have to monitor. So you take that complexity, mix it with the scale, and take a guess at what our Nagios look like. Just guess. Something like this. Basically all the time, every day, all the time. And it's not like everything's broken all the time. Our games are up. We pride ourselves on this. It's just that there's so many similar systems that we have to monitor, but whose behavior changes ever so slightly or changes over time. Say when we release a new game and players migrate from an older Call of Duty to that new one. And often a lot of crit alerts will end up being temporarily okay. There's always good intentions to profile a change in behavior, to update those check thresholds. But sometimes, deadlines come up and they become temporarily okay forever. So we had a NOC team at the time with a bunch of junior sysadmins who would watch for alerts and triage them by running commands and run, et cetera. And honestly, this kind of environment is incredibly hostile to that. It's basically a lose-lose situation for these guys because every time an alert came in, they first had to find it in a sea of all the other alerts. Then they had to try to make sense of the often very cryptic output and try to understand what the impact to the gamers might be, and then make a decision. Is this a critical issue? Are gamers going to be impacted and we need to escalate to an engineer right now, like actually invoke the incident process? Or maybe it's it's probably not impactful to the gamers, so we can just acknowledge it. Maybe you run a remediation or two and escalate it to a team, for next business day or their backlog. Or maybe just ignore it, because we've seen it before. It's a known one of these temporary okay issues, right? Or maybe it's a service under maintenance or something. The cost, however, of making an incorrect decision is pretty high, because you either invoke an incident, page an on-call engineer, and it turns out to be a false positive and a wild goose chase, or you miss an outage, and the gamers, they notice it. And when the gamers notice it, they are sure to tell you about it on Twitter and Reddit and all that stuff, so we don't like that happening. As you can expect, morale on our team was incredibly low. Our turnover was incredibly high, and the team was just disengaged overall. But as long as the games are up, everything's okay, right? So I joined the NOC team in 2015 to be a senior engineer and to help upskill the techs on the team. And I became intimately familiar with their reality, and it sucked. I did not like it at all. My stress levels went through the roof. It was a crap job. And I wanted to do something about it. So I went to Demonware's senior leadership team, and I said, look, this sucks. I think I can do something about it. I want to try some things. And they said, go for it. Do whatever you got to do. Just make sure we maintain our SLAs. So that set a floor. That said, I got a green field, blue sky. We got some moonshot goals. We're going to make some synergy here. So I came up with a 4-step plan for definite success to get us out of the pit that we were in, buried under a mountain of alerts, basically putting our face in the fire hose, because I wanted to do some actually useful monitoring. So first and foremost, our team needed a rebrand. If we wanted to increase the value of the team, we had to think outside the knock. We had to change our focus away from just drowning in alerts. It seems we kind of did the same stuff over and over again, running the same commands or the same run books, the same remediations on the same servers all the time. So why don't we solve for that problem instead of just playing whack-a-mole? So we renamed ourselves to the monitoring team, and to reflect this new focus, we wanted to get on top of the mess of alerts and build tooling to empower engineers throughout the rest of the organization to build good monitoring into their applications from the get-go so that we could build reliability from the ground up. This, by the way, is Maurice. He's our monitoring prairie dog. He's our mascot. It's a really long, really stupid story, but he's our mascot, and we love him. So we'd accomplished all this by building ourselves an autoremediation tool. As I said, I came to Monitorama in 2016, and that was basically a theme, autoremediation. And it was a beautiful future. I mean, computers are way better than humans are at running the same tasks over and over in response to the same alerts. So let's just do that, right? Let's get her done. I actually don't know what we'd do next, after building the autoremediation system. But it's kind of obvious to me that if all of a sudden our NOC techs were no longer dealing with the same crap over and over, and they'd learned a lot by building the system, they'd obviously be more valuable for other things, and they could actually start building projects that would increase value, instead of trying to chase alerts and prevent the loss of further value, which in turn leads to more profit. Always a good thing, right? So we set out to design ourselves an autoremediation system. Turns out these things are actually kind of easy to design, at least on the high level, because they basically consist of 3 main components. First, you need something to check and make sure that things are working the way they're supposed to, and alert when they're not. Then you have some sort of processing engine that takes that alert, validates it through some sort of calling out to various data stores and other APIs, and decides what remediation to run. And then that's shot over to a remediation runner, which does the dirty work and tries to run whatever remediation it is. The next time the check runs, if it's successful, great, autoremediation worked. If not, another alert's generated, it goes back through the chain, and can probably go, at that point, escape out to a human or something. The remediation failed, we need more help. Easy, right? So the design, since I said, it clearly splits into 3 separate problem domains, and we tackled each one individually, doing product evaluation, high-level requirements, et cetera, trying to do it right. The detection component was the easiest, actually. As I said earlier, we were using Nagios, and I think our main requirement was not Nagios. And we took a look at a ton of different offerings in this space, and honestly, there's just one answer. Sensu. I mean, we love Sensu. At least, actually, caveat, we love Sensu V1. Don't know if I'm sold yet on this V2 stuff yet. We'll see. But it supports Nagios checks out the box, which would make any migration much easier. It's incredibly extensible and supports custom attributes, filters, handlers. We can do all kinds of crazy things with it. And it's designed from the ground up for scalability. Perfect. The next layer is the decision layer, which takes the alert event and makes a decision about what to do with it. Since we wanted to make strong, high-quality decisions that could be used confidently for autoremediation, we really wanted to incorporate our other data stores. And in games, things are kind of weird, so we have all these funky custom things. So we need to be able to write our own things. We can't just go, unfortunately, with a web-based third-party provider and just magically things work. So I remember discovering StackStorm, which billed itself as IFTTT for ops, if this, then that. And I kind of realized that's exactly what we wanted. It's a super easily definable rules engine that allows you to take a trigger from some sort of event, run it against rules, match some criteria, and then run some actions based on it. And it's super easy to understand with a YAML-based language. And it comes with a ton of integration packs that they have in their community repo for all kinds of standard systems and applications. And their documentation is super good. So we were able to write our own integration packs for all of our custom stuff. So all of this makes it super easy to put together a rule that says, if an alert for this service fires and it's Thursday between 3 p.m. and 6 p.m., page that guy. Otherwise, don't do anything unless it's 7:15 to 7:22 and it's a full moon the previous week, then page that guy. So lastly is the remediation runner. How do you actually safely pull the trigger? This is terrifying. Like, this is actually the hardest thing. And we had major concerns and worries here. You know, how do you run remediation safely? Do we have like a centralized server that had keys to our kingdom, to every server in the data center that could run in and run things? Did we have a remediation agent that we had another piece of complexity now, another chance for things to fail? How do we handle permissions? Do we give it root? Do we run it to specific users and make everybody change their users for things? You know, how do we even make sure that remediations are safe? I mean, if a human's writing a script to be run after a certain kind of combination of actions, what's to say they don't make a mistake and forget to sanitize a variable and that rm-rf/ $directory becomes just null, and all of a sudden we've just toasted 4,000 servers at once? How do we even track success versus failure of remediations? And then like, what's the cost of auto-remediated failure? Like, what happens if it doesn't work? And how much risk in the end are we willing to accept? So after a lot of hemming and hawing and honestly a lot of stalling, we just decided to kick the can down the road. It's a problem for future us. We could build the detection and decision components for our MVP and stub in a human for that auto-remediation layer. It's kind of what we're doing right now anyway. And maybe we'll hope that we have an epiphany along the way. So we got started. We kicked off the whole project with a migration from Nagios to Sensu. This was an incredibly daunting task because we had well over 100,000 services across 5 different Nagioses. And our plan of attack was to go through that inventory of services in buckets, you know, and figure out what to do with them. Migrating them directly to Sensu because they're good checks. Maybe deciding that they were good checks, but they needed some more massaging to make them appropriate for auto-remediation. So we'd work with teams and do a quality review. Or we'd say that, you know, this is crap and let's just turf it. So on our first pass, we tackled base system checks. You know, the stuff deployed to basically every host, every node in your infrastructure. You know, load average, CPU, memory, that stuff. We cut a few, we tweaked a bunch of the scripts, and we eventually set them up in Sensu and disabled them in Nagios. So that brought us down from 100K to about 60K services left. Awesome. This is going to be easy, right? So next, we look for the most common checks based on how many systems they're deployed to. So with these, we worked with the teams that owned the services that they were checking to make sure that checks are still doing what they're supposed to be doing, that the output's useful. Because you know, if we're going to go through the effort of migrating all these checks, we want to make sure we're not migrating crap. So after going through about the 10 to 20 most common checks, we were down to about 40,000 services left in Nagios. And so we moved on to the next bucket, which is the top offenders. These are the checks that hurt us the most, that sucked, that they alerted over and over, and we compiled it by gut feel, by the pain index, basically. And we did the same as we did in the previous pass, by talking to teams that own these services and figuring out what to do with them. Frustratingly, a surprising amount of these painful checks, as soon as we talked to the team that owned the service, they said, just cut it. They didn't even think, they were surprised that it was still active. Why were we responding to it? Cool. So that left us with about 30,000 checks left in Nagios. And that's an incredibly long tail. I mean, a ton of the services left in Nagios are just deployed to a few servers here and there, snowflakes all over, and we need to figure out how to tackle this pile. We did not want to end up in a situation where we supported both Nagios and Sensu, making another temporarily okay kind of situation. And I think eventually we just realized, I think, like with dread in our stomach, that there's no way out of this. There's only one thing we can do, and that's go through them one by one. I remember waking up in a cold sweat once, like hitting this realization there's no way out of it, because it's so much work. But unless we wanted to continue the tradition of low quality, which is what caused that previous situation before, we had to do it. We just had to suck it up and do the work, do it good. We had to basically no longer accept failure. And so I declared that so. There is no such thing as an OK alert. So this is a huge mind shift for my team. Although, honestly, when I was making these slides and writing it, I realized this is going to sound so dumb when I say it out loud. It's so obvious. But if an alert is generated, it's because someone configured it to do so. That's the entire purpose of a check. To check and make sure that something is returning something that's expected, and if not, generate an alert because someone cares about it. Therefore, every single alert requires follow-up, because either the alert indicates that the thing that it's checking is broken and therefore needs someone to fix it, or it means that it's not configured properly. You're not actually checking to see if it's working or not. You actually don't know. So you're in a bad, it still needs to be looked at. As I said, it seems kind of obvious, but I think we've been focusing for so long on the alerts that we forgot that they're indicative of actual problems underneath. So we decided to do something about this. We set up a workflow in StackStorm that takes alerts coming through the pipe and calls out to a couple of those external data stores and validates the alert, and then dumps them into Slack, into a Slack channel. And that gave us sort of a flow of the alerts as they came in. And we started to see some interesting things. Like, first of all, we got a feel for the pacing, how often are alerts occurring? And then we could start to see like sort of primitive correlation. A bunch of alerts came off from a bunch of different systems, but about around the same time. There's probably a similar root cause there. This isn't actually a view that we could get from a dashboard system like Nagios or Uchiwa even. And we started to make tickets based on sort of the problems that we were seeing, not just the alerts. Later, we set up another StackStorm workflow that took those alerts as they went through the pipe and created a Jira ticket out of every single one. Because now we had a tangible artifact that is a consistent artifact across our entire organization. We all speak Jira and use Jira to track our work. And we could start to actually track the life cycle of the alert. We implemented Jira Service Desk, which gives us a queue-based view and some SLAs and all that stuff too, and a ton of metrics. And we started working on these alert tickets. And I gotta tell you, this was incredibly painful. I think every project manager in the company hated my team, because we just dumped hundreds upon hundreds of tickets into teams' backlogs. But then a funny thing started happening. Suddenly, alerts that had been problems for a long time started to get fixed. Underlying problems were being discovered and actually solved. This chart shows the volume of alerts, moving average over daily volume over moving average over 4 weeks, sort of smooth that out a bit. With the total alert volume in goldenrod, the Nagios volume in blue, and the Sensu volume in red. Even as we were migrating checks from Nagios to Sensu, we were still massively reducing the volume of alerts because things were actually starting to get fixed. It started to get clear to us at this point that this whole plan might actually just work. So we went back to our design and took a look at that remediation layer again. I mean, if we're seeing so much success like without an auto-remediation runner, why should we actually invest in that opportunity cost and that development time in that potential risk? I mean, our stubbed in humans have been so good at this. They're way better than computers at making fuzzy decisions based on uncertainty. Like, you don't need 100% certainty to do something. What if we use computers for what we're good at, what they're good at, and humans for what they're good at, and optimize for that? Then we wouldn't have to worry about that pesky remediation layer. And focusing on assisting humans to find real problems, making it easier to fix them, was a direction we hadn't actually considered. So we pivoted and ran headfirst in that direction. So we built a stack, we call it RAS. It stood for Remediation as a Service first, because we were expecting to build that. We didn't, but it's still, the name stuck. It's an assisted remediation platform, and it performs 4 major monitoring functions. So detection of problems is done by Sensu, as I mentioned earlier. Decisions about what to do with alerts are handled by an alert processing workflow that we built into StackStorm. And then those validated alerts are then enriched through a widget system that we also built in StackStorm, which allows for us to query additional data and add them to the alert object. And then lastly, those enriched alerts are escalated through a Jira workflow that we built in StackStorm, which creates Jira tickets and routes them to the appropriate team or to a specific engineer, on-call engineer, based purely on the properties of the alert. RAS allows us to detect issues and handle them in a consistent fashion from tip to tail. And it codifies what's become sort of our monitoring philosophy. So this has been a pretty trying journey at times. There's a lot of hard questions that we tackled that we didn't realize it would be as hard as it was. We thought it'd be kind of easy, as I said. And there were points where we literally sat back and said, what are we doing? What is our purpose? What is monitoring? And we thought long and hard over the past about 2.5 years here. And this is going to sound a bit new agey, but we've kind of come up with a bit of a philosophy that describes our approach. And we kind of go back to this every time we design a new system or anything. We try to encompass what I call our monitoring maxims. I think some of these are, they're not tech specific or even specific to our organization. So hopefully they might be useful to you too. So first and foremost, humans are expensive. Don't waste their time. As I mentioned earlier, our engineers are busy making awesome video games, and we got deadlines. They're not going to push back the ship date because an engineer needs to finish an alert, right? So if the interruption turns out to be a false positive or something that a computer could have done, we really should let the computer do that, implement automation where it's useful, and then use humans where they're super useful as well. However, it's got a corollary. Humans are expensive in another way. They're super clever and creative and incredibly inconsistent and unpredictable. I am constantly amazed at how they manage to break things. And I mean, humans are going to be human. They're going to make mistakes. The thing is, though, is that's OK. It's OK for humans to make mistakes. It's not OK for computers to make mistakes. Humans can learn. Computers, well, we have to learn first and then code them to do better. So if we can make it safe to fail, if we can limit the impact that a human might have, then that seems perfect. That's what we should do. We need to focus on getting the humans to do the hard thing and then automate everything else. So we built a constellation of tooling that interact with RAS to basically empower engineers to do their job without having to log into servers, without having to touch prod, basically, until they're ready to do a mitigating action. And even then, if we can make that just a button click, then that's a huge win. We really want to chase an ideal where a human receives a validated page, a real problem, diagnose it based on the data that's in that page, make a decision based on that data, and invoke a mitigating action all from their phone on the beach. Hashtag beach ops, right? Since our humans are expensive, though, we need to keep our pages holy. Every time we page a human, the issue must be urgent, and it must be incredibly important that they specifically who answered the page, is the one who responds. Every single time a false positive is escalated to an on-call engineer, and it ruins someone's day, it's less likely they're going to respond the next time they get paged, and that might be a true crisis. So we implement this in RAS by defining checks with only binary states. We don't use warn or unknown. We only use crit and OK. It's either working or it's not. We codify the urgency of the response required directly into the check itself as either high priority, we need an engineer right now, page someone, or low priority, make a ticket and stick it in someone's backlog to be dealt with next business day or whenever they feel it's important. We also focus on monitoring for success. We found that many checks were looking for very specific failure conditions, and in reality, that's a cat and mouse game. And every time something broke, we get like 10 alerts for this same system, the same problem. I just want one thing telling me it's a problem. Is it broken is a very different question than what is broken. And that latter question can be answered after you've detected a problem and escalated it to an engineer. When we reviewed checks during our migration, we pushed to implement checks that look to verify that the business value is working, and then alert if that's not a true statement. The reason that you built the thing in the first place. Additionally, we aggregated a bunch of these failure-specific checks into a single check that would alert if any of those conditions are false or alert. And through this, we get a strong sense of the overall health of our systems, not just a list of individual failures. And that greatly reduced the alert volume and noise. Complexity always extends incidents. This was touched on yesterday as well by another talk. The more complex that a check is in the way that it works, the more complicated a remediation is, the more chance that there is that someone's going to screw up. I mean, we're human, as I said. When we reviewed checks during the migration, we pushed back against complexity. If we couldn't understand what it meant when it alerted, it's almost guaranteed we're going to screw up somehow. And we also pushed back on complicated remediations. I mean, if fixing it was as easy as running 15 different commands across 4 different servers, cool. Just wait till I break it. Restoration is more important than investigation. If something's broken, if our games are down, it is critical that we mitigate the issue first and bring the games back up, then figure out what went wrong. We found out that when we escalated issues to our on-call SREs, they often spend about the first 10 to 15 minutes when responding to an issue by looking at dashboards, looking at logs, logging to servers and typing W a bunch of times. And And they often did it inconsistently as well. Different engineers looking at different data, different dashboards based on their expertise, and coming up with different decisions. And then we thought, wait a second. If the alert's going through our system anyway, and we're already pulling a bunch of data in order to figure out what's wrong, or like if it's a valid alert or not, why don't we pull some of this data too and add it to the alert as the object's flying through our pipe? Then we can actually stick it into the JIRA ticket, and the engineers, when they get the page, they already have all the logs. They already have the graphs. So you know how in Star Trek, every time the ship gets hit by a torpedo, there's an alien race, and there's a fight, and everybody on the bridge, they shake for a minute, and then one of the crew members looks at a random terminal and instantly says, life support's at 48% on decks 2, 4, and 6, shields are at 32%, we got hull damage on decks 2, 6, and 8, and the doctor's offline. And the captain immediately says, all right, let's do this. They make a narrow escape, and everyone's happy. That terminal wasn't configured to show that data, but the ship's system knew that based on these events, this data might be useful in order to make a decision. It didn't know what decision to make, but it knew that if it told a human that, they could make a good decision. That system's called LCARS in Star Trek, and that's the system we built. We called it LCARS too, because we're super clever. We originally called it Star Trek Diagnostics, but that becomes STDs, and we're very immature. Our LCAR system, as an alert goes through, this is actually defined in the Sensu definition itself, what dashboards to pull, what log, like an Elasticsearch query to make that gets populated into the JIRA ticket, maybe the statuses of some of our first-party systems like PlayStation Network, Xbox Live, or Steam. The last few alerts that occurred for this system, so you can just see it all there. You get context. So we implemented all this stuff, and it made a huge difference. When we embodied all of this stuff into our RAS stack and into the future, into all the other additional monitoring tools that we make, we've seen a huge benefit in terms of our alert volume. It's really made a huge difference to our lives. The alert volume is down significantly by orders of magnitude. We used to schedule sysadmins 24/7 to handle that deluge of alerts, but now we're clawing back that active coverage and moving to a purely on-call model for out of hours. We went from thousands of alerts per day to tens of alerts per day, and oftentimes less than that. Since we track every single alert as a JIRA ticket, every alert has an audit trail. And this amounts to a ton of data, not only about the failure, but also the responses. And that allows for trending, prioritization, and allocation of resources across our entire organization. And then again, as we fed that data back to the teams, they were able to make decisions on them. They were able to fix long-standing bugs, improve their support processes, and improve their overall reliability. With more valuable, useful escalations being routed to teams, they have greater incentive and opportunity to fix and make their services significantly more reliable. Demonware has always prided itself on the reliability of our games, and we further improved upon that high standard. And lastly, and most importantly to me, the monitoring team's morale is night and day from where we started. The NOC team was terrible, but the monitoring team is the best team in the company, in my opinion. Since we built this system ourselves, we had to learn how to do it. We had to learn how to code, actually. We had to learn how to use Docker. We built a CI/CD pipeline. We learned how to do unit testing, all kinds of stuff, all while maintaining our SLAs. Every single step of the way has improved the quality of life for everybody on the team. We've taken our careers to the next level, every single person, and we've significantly improved the overall engagement of the folks on the team. I'm incredibly proud of my team and everything that we've accomplished. So we never did end up building that auto-remediation system we set out to build. Completely failed at that deliverable. But in the end, we didn't have to, because we found out that by focusing on the humans, by making it easier to actually fix problems, that's a better solution anyway. Thank you.